we will see all these formulas in one video itself. I have put all together in the single video because all these are interconnected, so I thought you will be able to understand better if I put all this into one video. So let me just start with an example to make it easier for you. Say for example, I have been given a data like, let's say, 582. So this is the data given to me. So this I'm keeping as x. These are the observations under x. So the value of x is 5, 8 and 2. So what do I have to find out? First of all, standard deviation. So standard deviation, so this is what I'm finding first, standard deviation. Okay. So standard deviation's formula is, so I'm writing SD. It is also denoted like this. Okay, standard deviation is equal to root of summation. Summation means total. It is written. So this is the symbol. Summation of x minus x bar the whole square divided by n minus 1. Okay, so this is the formula. Summation of x minus x bar the whole square divided by n minus 1. Now the observations given to me are 5, 8, 1. So what I need as per the formula is x minus x bar. So x bar means mean. So x bar is equal to, I'll just add 5 plus 8 plus 2 divided by 3. So arithmetic mean average I am taking. So 5 plus 8 plus 2 comes to 15 divided by 3, that comes to 5. So x bar is 5. Okay, so x bar is 5. Now x minus x bar. So what is x minus x bar? X is 5. So 5 minus 5 equal to 0. And then 8 minus 5 is equal to 3. And then 2 minus 5 is equal to minus 3. So if I try to summate this, or if I try to total this, x minus x bar, you see it will come to 0, because plus 3 minus 3, it will come to 0. So it will always come to 0, not only for this number. You take any number of observations and you try, it will always come to 0. Reason being, each number I'm connecting with the mean. So finally, some numbers will be bigger, some number will be smaller than the mean, and when I try to add up all, it will give me 0 value only. Okay, so there is a problem, and that is the reason why this formula is modified. This is telling me, see, already this is telling me the deviation, x minus x bar. So how much x is deviating from x bar, that's what we wanted, deviations. But then, because this is giving me always 0, what I will do is I'm adjusting this formula and then I'm squaring it up. So now instead of x minus x bar, I will do x minus x bar square. So it will become 0 square, that will be 0. This, when I square, it will give me 3 square is 9. This, when I square minus 3, it will also give me 9. So 9 plus 9, this will give me 18. So this is what, this is summation of x minus x bar the whole square. This is giving me 18. Okay, x minus x bar the whole square is giving me 18 here. Okay, now I'm standardizing this. That's why I'm dividing by n. Okay, now why am I doing n minus 1? See, if I would have done population standard deviation, there is something called population standard deviation, and there is something called uh, sample standard deviation. For population standard deviation, the formula will be summation of x minus x bar the whole square divided by n. So why am I doing like this? See, I'm squaring it. I told you the reason is, otherwise I will get 0 only, x minus x bar. And then to standardize, I'm dividing by n, total number of observations. Now because I squared it, to nullify that, I'm doing square root as well. So this is the logic behind the formula. Because I'm squaring, so in order to nullify that effect, I'm doing square root as well. So the population standard deviation will be uh, root of summation of x minus x bar is 18 divided by 3. So that will come to root of 6. So root of 6 for me will be 2.449. So this is the answer, 2.449. This is population standard deviation. So what do you mean by this population standard deviation? When I'm taking the entire data, then it is called as population standard deviation. Sample standard deviation means when I'm taking some samples out of the entire data, entire population data, because I don't want the entire data, because if I go to collect the entire population data, it will be too costly or too time consuming. So I'm going for only for samples. So when I'm taking sample, in that case, I will use the formula as sample standard deviation will be summation of x minus x bar the whole square divided by n minus 1, and then I will root it. Now why do I do n minus 1? Because when I do minus 1, the denominator will become smaller, and so this entire number will go little bigger. Okay, so when this entire number goes little bigger, it will kind of bring in more accuracy. Say for example, see, if I'm taking a confidence, if I'm taking a normal distribution, assume this is a normal distribution, any data maximum, like any data goes in normal distribution when you distribute, right? So in a normal distribution, see, this, imagine this is population distribution, population data distributed normally. Now this is the mean, this is the mean. Now when I go for a sample one, imagine this is the sample, I have taken sample, and this is the mean. Now you see there is a difference between my sample mean and the population mean. Okay, so now this difference is very huge, and this is not even forming a part of my sample mean. So in order to bring in more accuracy, I want this number to be little bigger. So when it will be bigger, what will happen is this distribution will cover like this bigger way. So when it goes in the bigger way, at least this population mean is also a part of my sample mean. So that's what I want as a statistician. So to bring in more accuracy, I will do minus 1 over here, so that the number goes bigger and it comes closer to the population mean. So that's why the formula is root of summation of x minus x bar the whole square divided by n minus 1. So in this case, sample standard deviation will be root of summation came to 18 divided by 3 minus 1. So it will be root of 18 by 2, that will be root of 9, that is equal to, so 9 root, it comes to 3. Okay, so sample standard deviation is 3 and population standard deviation is 2.449. Okay, all right. So this is sample standard deviation. The next one is variance. Variance, it will tell me how far a set of number is spread out from their average values. Okay, so variance is a measure of dispersion. So the formula for variance is equal to, okay, so when I square this standard deviation, so standard deviation, when I square, I will get variance. Okay, so this will tell me the the spread out numbers, how far the deviations are spreading out. Okay, so standard deviation in this case 3, so 3 square, this 3 square is equal to 9, 9 becomes the variance. Okay, this is sample variance. Similarly, if I want to go for population variance, I will do 2.449 square. Okay, so the formula for variance is equal to standard deviation square, or I can further write as summation of x minus x bar the whole square divided by n minus 1. Okay, so I'm just removing this root effect I'm removing. Or you can think like this, this is standard deviation and then I'm squaring. So when I square, this square and square root gets cancelled and I will be left out with only this part. So this is variance. Okay. The next one is, the next formula is covariance. Now for covariance, how I can find out is, the formula for covariance is equal to summation of x minus x bar into y minus y bar divided by n minus 1. So this will tell me how two variables are moving with each other, how two variables tend to move together. Okay, how two variables tend to move together, how two variables, so whether they are moving together or not, that's what I'm getting to know, how two variables tend to move together. Okay, or if two variables are moving together, that's what I get to know. So here let me take the same example that I did first, 582, and then I got the mean as 5. Sorry, the mean is, yeah, mean is 5 here. Okay, 5. So x bar, so this is x, and then y, let me think of another number, let's say 3, uh, 5, and then 1. Okay, so total comes to 9, and so 9 by 3, y bar is equal to 3 plus 5 plus 1 divided by 3. So 9 by 3 is equal to 3. Y bar is equal to 3. So now uh, summation of x minus x bar we have already done. Summation of x minus x bar is, okay, sorry, yeah, so here how I will be doing here is summation of x minus x bar, but it is not alone, I also have y minus y bar. Okay, so x minus x bar into y minus y bar. So x minus x bar is 5 minus 5 into 3 minus 3. Okay, first one. Second one, 8 minus 5. So by the way, for this first one, it will come to 0. Second one, 8 minus 5 into 5 minus 3. So 8 minus 5, 3, 3 into 2, 6. And then 2 minus 5 into 1 minus 3. Okay, so 2 minus 5 this one, and this one 1 minus 3. So this comes to minus 3 and then minus 2. So 3 twos are 6. Okay, so the summation comes to 12. Okay, yeah, so summation comes to 12. So covariance is equal to summation of x minus x bar into y minus y bar is 12 divided by n minus 1. N is 3, 3 minus 1 is 2. Okay, so 12 by 2, that comes to 6. So 12 by 2, that comes to 6. So when I get this positive number, I can say that these two variables x and y are moving together. However, it doesn't tell the strength of the linear relationship. So the relationship is linear between x and y. The relationship is linear. So what does that mean? The relationship is linear uh, between x and y. What does that mean? That means if x goes up, y also has the chance to go up. However, I don't know the strength of the linear relationship, so I cannot say to what extent this relationship is powerful. Okay. However, so the negative point of covariance is, however, it doesn't tell me the strength. However, it does not tell me the strength of the relationship. Strength of the relationship. Okay, however, it doesn't tell me the strength of the relationship, and that is why I will come up with another formula called R, that is correlation. So correlation will help me to tell the strength of the relationship between x and y variable. So R is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. Okay, so covariance here, covariance I have got as 6. Okay, so covariance is 6. Standard deviation of x, I got it as 2 point, I think 2.5 I got, 2.5 or 3. Standard deviation is 3. Okay, I got it as 3. So 3 into standard deviation of y I have to find out. So standard deviation of y will be, so I just do it here. Standard deviation of y, okay, I'll have to do it separately here. So standard deviation of y, so it is standard deviation of y is equal to root of summation of y minus y bar the whole square divided by n minus 1. So I need y minus y bar the whole square. So y I have here y minus y bar. So let me find out here y minus y bar. So first one is 3 minus 3 and the square as well. So 3 minus 3 is equal to 0. Okay, so y minus y bar square, then 5 minus 3 square, so that comes to 4. 1 minus 3 square, that comes to 4. So total is 8. So standard deviation of y is equal to root of 8 divided by 3 minus 1. So that is equal to 8 by 2. So that is equal to 4. Root of 4, that will come as 2. Okay, standard deviation of y is 2. So here I'll write 2. So 6 by 6, it comes to 1. So okay, so this is just a coincidence that by chance it has come to 1. So R will basically, you will get from minus 1 to plus 1, minus 1 to plus 1. R will be in the range of minus 1 to plus 1. Plus 1 means it is called perfectly positively correlated. So in this case, it is perfectly positively correlated. So what does that mean, perfectly positively correlated? That means if x is going up, y will also for sure go up. Okay, the strength is very, very strong over here. Similarly, minus 1 means it is called perfectly negatively correlated. Perfectly negatively correlated. So what does that mean? If x is going up, for sure y will come down. Okay, and their relationship can be in between as well. So in between means what? 0.4, 0.5, 0.7. So it can go like this as well. So this is R, correlation. Okay, then the next formula that we are supposed to see is correlation, then beta and standard deviation of the portfolio. So beta, okay, so I'll write here. So beta is equal to covariance of the stock and the market. So x and y variables I took, right? So in this case, it will be covariance between stock and the market. So if stock is x, uh, market is y. So this way you have to think, stock and market. So I'm connecting, or I'm finding the relationship between a stock and the market. So standard deviation of stock, and then sorry, this is not the stock, it is standard deviation. No, it is variance of the market. Okay, variance of the market, variance of the market. So if I take x and y variables, we take x as stock. Okay, so whatever data, like whatever data I had put here, this is stock. So this will be, let's say, the market, that means Nifty. Okay, Nifty. So in that case, Nifty, or Standard and Poor's 500, whatever index you want to take. Okay, so in that case, so market variance, so I'll find out the standard deviation and then I will take square, so it will become variance. Okay, so here covariance was for me, covariance was 6. So covariance was 6 for me, and then variance of the market, so standard deviation of the market was y, sorry, 2. So standard deviation was 2, so I'll take 2 square, so 6 divided by 4, so that comes to 6 divided by 4 comes to 1.5. So 1.5, this is the beta. Okay, this is the beta. So that means if Nifty goes up by 1%, this stock will go up by 1.5. So high beta. More than 1 is considered as high beta. Okay, so high beta or highly volatile risky stock. So if Nifty goes up by 1, this stock will go up by 1.5. Okay, and similarly, if Nifty goes down by 1, this stock will go down by 1.5. So this is telling the intensity or the strength, with the market. Okay, this is beta. Standard deviation of your portfolio, this is for 2 assets. So the formula for standard deviation of your portfolio is equal to root of weight 1 into standard deviation 1 whole square plus weight 2 into standard deviation 2 whole square plus 2 into weight 1 into standard deviation 1 into then weight 2 into standard deviation 2 into R. That is correlation. Now why the formula is like this? Because see, standard deviation, this is the first standard deviation, and how do I find out this? Standard deviation is equal to root of summation of x minus x bar the whole square divided by n minus 1. This is for sample standard deviation. Now once I find out this standard deviation, I will write it over here, and the weight that I'm allocating to that asset. Let's say here I'm allocating 40% weight. So weight is 40% into that standard deviation and then whole square. Okay, plus the second one. So here it will be remaining 60% weight, and then this standard deviation. Okay, so ideally the formula should end over here, but then however, if you see, the formula gets extended here. Why so? Reason being, because quite possible that both the assets are correlated. Now because they are correlated, which is represented by R, so based on based on one asset, the other asset might deviate, and based on the second asset, the first asset might deviate. That's why the standard deviation of the portfolio, it gets extended, and I'm writing here as 2 because twice it happens. Okay, so twice, because of one asset, another asset gets deviated, and because of the second one, first one gets deviated, and that will deviate by the by the correlation that they both share. Okay, so that happens because two assets are there, so I'm multiplying by 2 over here. That's why the formula gets extended like this. Okay, so this is the formula for standard deviation of the portfolio. Hope this is fine, and thank you so much for watching it. Thanks a lot.